so the top of the page looks like this. We did this one, and then we wanted to stop. I stopped here. But, again, this should be negative 5t squared because I scribbled something down and I didn't have it right. So if you didn't write down the velocity, I don't know if I had, did I have y'all write it down? If you wrote down what I had on Friday, it needs to have a negative in front of it. That's the only difference. Okay. All right, so let's go through and read this question. Do our thing here. So train A runs back and forth on an east to west section of railroad tracks. Remember, we can go left and right. Train's A velocity measured in meters per minute. So the velocity in meters per minute is given by a differentiable function, the v sub a of t, where t is measured in minutes. Selected values for the velocity are on the table below. At time t equals 2, train A's position is 300 meters east of origin station, and the train is moving east. Okay. All right, second train B, travels north from origin station. So remember, we can go left and right, or we can go up and down, but it's only one of those two. At time t, the velocity of train B is given by, not by t, but by this that we rewrote. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. That's a lot of information, right? Okay, so here we go. Because we're moving in two different directions, and we need to know the rate that the distance between them is moving, let's draw ourselves a picture. Okay? This is origin station. I was going to put an O, but I don't want it to look like a 0 and be confusing, so we can put, I'm not even going to put a letter, but this is origin station. Let's just do it that way. Okay, so train A is going back and forth east and west, so this has to be A. This is train B, it's moving north, and the distance between the two trains is going to be C. So it's a right triangle. We got some Pythagorean theorem stuff going on, right? At time t equals 2, which is what we're dealing with here, train's A position is 300 meters east, because it's moving east. Train B is moving north, and at t equals 2, this is 400 meters north of the station. Well, at t equals 2, can we figure out what the distance between the trains is? Yes. This is 3, this is 4. What would this have to be? Remember your Pythagorean triples? Like the basic one that showed up over and over again? 3, 4, 5. It's a 3, 4, 5 triangle. So 300, 400, 500. If you didn't know, you can do Pythagorean theorem. Okay? So it's 500 meters. So what we are looking for, the rate in meters per minute at which the distance between these is changing. That means we need dc dt. I am looking for this in meters per minute. Does that make sense? Because you're looking for a rate, so it's the derivative. Do we know C right now? Yes, it is 500 minutes. Meters, not 500 minutes. All right, so then I would need, what about dA dt when t equals 2? Can we figure that out? Yes. What's another way to say dA dt? What does dA dt represent for our train? The velocity. So isn't this just another way to say dA dt? Okay? The velocity is dA dt, right? So when t equals 2, what's the velocity? 100 meters per minute. Thank you. All right, so at t equals 2, do we know A? Yes, it's 300 meters. Okay, so then we need dB dt, right? Exactly. This is the same thing as dB dt. It's just a different way to write it, right? So we can use that equation. I can find V sub B of 2. That would be negative 5 times 2 squared plus 60 times 2 plus 25. Not yet, because we're just finding this information. This is the velocity. So basically, this is the derivative for B, right? They gave us the derivative for B. So this is equal to, so 2 squared is 4 times a negative 5 is a negative 20 plus 120 plus 25, 125. Okay, so the velocity is 125 meters per minute for train B. And what is the distance B? 400 meters? So this is the derivative for A. This is the derivative for B. We need the derivative for C, so we need to actually find the derivative. This relationship here is A squared plus B squared equals C squared. Right? So that means I get 2A dA dt plus 2B dB dt equals 2C dC dt. Everybody okay with that derivative? Can I simplify that sum? Yep, I can divide the whole thing through by 2. So I get A dA dt plus B dB dt equals C dC dt. So now that I've taken the derivative, now I can substitute this information in. Okay, I don't get to substitute this stuff in until I have found the derivative. I did substitute something into something else, but that was to get part of this information. So A is 300 times dA dt, which is 100, plus B, which is 400, times dB dt, which is 125, which is equal to C, which is 500, times dC dt, which is what I'm looking for. I just divide by 500. So I could say that dC dt is equal to 300 times 100 plus 400 times 125 all over 500. And what are my units? Meters per minute. I just realized I didn't put I just put M over M, meters per minute. And that's a safe stop. That works. Okay. We good? Any questions? All right, so let's go ahead and clean this up just for the sake of actually doing it. So this is a safe stop here. Okay, so 300 times 100 is going to be 3 with 4 zeros, right? Plus, what's 4 times 125? What's 2 times 125? 250. Double that again, you get 500, and then I add 2 more zeros on it, so it's 5 with 4 zeros all over 500. So that is 80,000 divided by 500. You can divide the top and the bottom by 100. And then, so then I just have 800 divided by 5. So 5 goes into 8 once with 3 left over. So that would be 30. So then that would be 6 and then 0. So it's 160 meters per minute. What questions you got? We good? Drawing the pictures can help, especially if you got 2 trains doing something, you need a picture. Okay. Well, good? Okie dokie.